Let's talk about percentages. Percentages are used everywhere. So I guess we should talk about is what is a percent? When we talk about a percent, we are talking about parts per 100. So parts per 100. Like if we say we have a mix of 12% concrete, what does that mean? It means we have 12 out of 100 parts are actually concrete. Sometimes we use the word rate instead of percent. And sometimes that'll equal percent as well. And we'll use that in like failure rate. So we're actually asking about the percentage, or maybe it'll be the rejection rate. Again, we're talking about percentages when we talk about rates. Sometimes we will look at percent as a fraction. And we can also get percent from that as well. So we can say 3/4. And if we put that into percentages, that'll be 75%. Or vice versa, we could say, construction project that we're 75% done with the framing. What does that mean? We're actually 3/4 of the way done. So how do we go about converting? For instance, you may already know that 75% equals 3/4. But why is that? Well, let's grab the calculator real quick and take a look. So if we take 3 divided by 4, we are going to get 0.75. Now you'll notice the difference between 0.75 here and 75 is the decimal point. So if we have a decimal number, to get percentage, we simply have to move over the decimal point 2 places to get 75. If we have a decimal point, if we have, I'll just say 0.50, so we will have to move the decimal point 2 places, right? If we do that, we end up with 50, and that is 50%. If we have 125%, we move the decimal place over 2 places. 1, 2, and that's going to equal 1.25. So we can convert from decimal numbers to percentages simply by moving the decimal point. Let's solve some percentage problems. Now I'm going to show you a way I think of these. I think of it as the triangle here, and I'm going to put A up here. A is going to be our amount. B times P. Now A, like I said, is going to be our amount. B is going to be our base, and P is going to be our percent. And so you can solve a lot of simple percentage problems using this little triangle. So let's come up with one. If we say we want to know what 35% of 80 is, well, what do we know? We know that our P stands for percent, so I'm just going to draw my little line here and put 35% here. And I said 35% of 80. Well, is 80 our base or is that our amount? Well, if you hear me say of 80, 35% of something, that is your base. And so I'm going to put 80 right here. So what we're trying to solve for is the amount. So we can do this fairly easy. We're going to take 80 times our percent, which is the same as saying 80 times 0.35 in decimal. Remember, we moved the decimal place over. And what is 80 times 0.35? 80 times 0.35 is 28. So A is going to equal 28. So 35% of 80 is 28. Let's try another one. 3.74% of 3.47% of 5,710. Well, we know our percent is going to go over here, so I'm just going to go ahead and convert it to decimal now. 0.0347. And I said the word of, and so what follows that is going to be my base. So I've got 5,710, and we multiply that out. 5,710 times 0.0347 equals 198.137. I've only got 4 significant figures at the most, and so I'm going to change that to 198.1. So how do we find the base when we know the percent? We already know our little triangle. Let's do this first. Let's find the base. When we know the percent. And we are already familiar with the triangle, our A over BP. I'll put my little time sign right there. So 12% of what number is 78? Well, 12% of what number equals 78? Now you heard me say of, the 12% of, so we know the 12%, so I'm going to put that down here as our P. There's our 12%. Of would be the base, which we don't know, and we do know the 78. We know our amount. So we can take 78 over 0.12 and find our base. Let's do that. 78 divided by 0.12 is going to equal 650. 140 is 25% of what number? So we know the 140 is going to be our amount, so we end up with 140 over 25% is going to equal our base, which is the part we don't know, which equals 140 over 0.25, which is going to equal 140 divided by 0.25. And the answer is 560. Let's look at the percentage of one number over another. Percentage of one number, in this case we'll just say percentage of X over Y. Well, as you probably just figured out when I did that, this is going to be pretty easy. If I want to know that 42 is what percent of 405, so 42 is what percent of 405? We know our triangle gives us our amount, and our amount is 42 over 405, which is our base. We don't know what the percent is, and so we're going to end up with that. So that is going to be 42 divided by 405 is going to give us our percent. And so 42 divided by 405 is going to give us 0.103. We got three significant figures here, 2 here, and this is going to equal 10%. We're going to have to take it times 100 to get our percentage, and we should get 10%. How about one where we're working on percent change? If we want to know the percent change, we have to know the new value, subtract the old value or the original value, that whole quantity over the original, times 100. So let's say we have a quantity that changed from 521 to 835. So we were at 521, we changed to 835. So our new value is 835. We're going to subtract the old value, 521, or the original value, and we're all going to be over 521. We're going to have to take that times 100 to get percent. So 835 minus 521 equals 314. So it's 314 over 521 times 100. So we're going to divide the 521. We get 0.6026. 6026. We multiply that times 100. And we get 60.26%. We have 3 significant digits, and so our final answer is going to be 60.3%. Sometimes we talk about machinery, we're going to talk about power efficiency. So let's take a look at efficiency. So how do we calculate percent of efficiency? When we do efficiency, we are going to be worried about the output of something over the input. Now the output is always going to be less than the input. Things never get more than 100% efficient in the real world. So you may hear of that, especially when we talk about things like heat pumps. But you're always going to input a little bit more energy than you're going to get out, at least from a motor standpoint or a piece of machinery. So let's take a look at these, and we'll use our conversion that we talked about in our last video. So let's say we've got a 1.12 horsepower motor, and it takes 865 watts of power to produce that 1.12 horsepower. So how do we calculate that? Well, the output is going to be in horsepower, the 1.12, and the input is going to be 865 watts. Now the problem we've got right now is we need these to be the same units. So we need to either change them both the horsepower or change them both the watts. Let's change this 1.12 into watts. And you could look up in Appendix B and find out that 746 watts equals 1 horsepower. And so we could calculate the 1.12 horsepower. Take it over 1, we multiply that, we multiply across, and we get 1.12 times 746. So that's 835.52, 835.52 horsepower. I guess I should have a P there. Watts. All over 1 times 1 horsepower, which is going to be 1 horsepower. The horsepower will cancel, which is going to leave us with 835.52 watts. All right, so let's go back to our original equation. Rather than the 1.12, we are going to sub in our converted number. So 835.52 watts is what we got out of the motor in terms of work, and we put in 855 watts. Now, we're going to get up a fraction, so we're going to have to multiply this by 100. But let's go ahead and do this. 835.52 divided by 855. 0.9772. So I'm going to do this before I forget. We're going to get this times 100. And we got 0.9772. This equals 0.9772 times 100, or 97.72%. We actually started out with 3 significant figures, so that is all we're going to need. And so we know that our final answer is 92.7%. So our motor is 97.7%. We'll do one last thing here. Let's look at percent of error. So the percent of error is going to look something like this. This is going to be our measured value we're going to subtract out our known value all over our known value. Let's take a look at one. Let's say we had a certified weight of 500 grams. So I'm going to put 500 here. That's our known value. That's what we're supposed to have. And the sample that we weighed was 507 grams. So we are going to take 507 grams minus the 500 all over the value it's supposed to be, 500 grams. It's going to give us a decimal number, so I'll have to take it times 100. 507 minus 500 grams is simply 7 over 500. We'll do times 100. So 7 divided by 500 equals 0.014. 0.014, and if we multiply that times 100, we get 1.4%. So that is how we find the error. So we have an error of 1.4%. How about percent concentration? We've got an application where we've got a fuel mixture. It's got 18.9 liters of alcohol and 84.7 liters of gasoline. So we have a percent of concentration. We have, what did I say, 18.9 liters of alcohol. Liters of alcohol, and we have 84.7 liters of gas. Now what we want to know is to find the percentage of gasoline in the mixture. So what we're going to have to know is the amount of A. So the amount of in our case we're looking at the percentage of gasoline, so for us it's going to be gasoline, so 84.7, and that's going to be over the total amount of the mixture. That's going to be in our case 18.9 That's going to be over the total amount of the mixture. And for us, that is going to be 18.9 plus our 84.7. So 18.9 plus 84.7 is 103.6. 103.6. And we've got 84.7 up here. This is going to give us a decimal number, so we're going to take it times 100. So 84.7 divided by 103.6 is going to give us 0.8175. 0.8175 times 100, and we multiply that out, we are going to end up with 81.75%. We had three significant digits to start with, and so we're going to end up with 81.8% of gas in our mixture. All right, let's talk about percentages. We talked about how to solve percentage problems, and we used our little percentage triangle, the amount over the base times the percentage. We talked how to find the base when we know the percentage, and how do we find the percentage of one number over another. We talked about how to calculate efficiency. We talked about how to calculate percent change. And finally, we looked at percent error and percent of concentration. Covered a lot of stuff, all to do with percentages. If you get any questions, please get a hold of me.